Hello, everyone. It's 1 p.m. Eastern, so it's time to begin our 95th CoCoRaHS Weather Talk webinar. A very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is my colleague Noah Newman. We're coming to you live from the Colorado Climate Center here in Fort Collins, Colorado. A big thanks to our donors across the country. Your gifts help support our Weather Talk webinars and many other CoCoRaHS endeavors. Well, exploring the Enigma. I got to say that word right. That is drought. And drought is the subject of today's Weather Talk webinar. Drought creeps, it lurks about, but sometimes it can come in on a flash. Don't really know much about this subject? Well, you're in luck, as we have my good friend Mark Svoboda here with us today. He's the director of the National Drought Mitigation Center, and he'll help explore this topic further. Mark has been with the National Drought Mitigation Center since its formation in 1995 as the National Drought Mitigation Center's monitoring program area leader. His duties include overseeing the center's operational national drought monitoring activities. His responsibilities include providing expertise on climate and water management issues by working closely with states, federal agencies, and international governments, as well as the media and the private sector. Mark co-founded the U.S. Drought Monitor in 1999 and serves as one of the principal authors of both the weekly U.S. Drought Monitor and the monthly North American Drought Monitor products. Mark is an avid Nebraska Cornhuskers fan, surprise, surprise, and a Green Bay Packers fan just like myself. Welcome, Mark. It's great to have you back with us today. Wow, Mark was last with us on this broadcast back in 2013. Mark, good to have you here. Hey, as we start things out, I usually ask each of our guests, how did you get involved in weather? What was it? Was there an event in your life? What kind of got you interested in this subject?
Yeah, good question. I can specifically remember what got me into it. A couple things. One was just a lot of outdoor activities here growing up in rural Nebraska with my dad, hunting and fishing. You always kept your eye on the weather, so you didn't get caught off guard. And secondly, though, probably most importantly, uh, was traveling on the road with my mom and had three funnels come across the highway about a half mile out, combined into sort of one little small sinewy tornado. And from that point on, I was kind of influenced by that event and went into meteorology when I got into college.
Wow, that's cool. Everybody's got a story, and it's usually an event or something like that that we become meteorologists from there. So thanks for sharing that. Hey, if you want to upload your screen and your slides, we should be ready to go here. So just we'll hit the share button, and Noah, maybe you can help him here with this part.
I think I'm getting there.
Got it? Okay, yeah, you're a pro at this.
Get into presentation mode here. Okay, now can you see full screen on that?
We can, and I'm going to go on silence, and I'll be back at the end of the program, at the end of your presentation.
All right, sounds great. Thanks again, Henry, for the invitation to speak. In fact, I think I was in your early days, like webinar number 16, so maybe 80 webinars ago. I think we did the last one on drought. So some things have changed, some things haven't, but I'm going to walk you through, as the title says here, sort of the conundrum or the enigma that is drought. And, obviously that means a lot of things to a lot of different people. So we'll just walk through it, but I want to give you just two slides on who we are and what we do here at the Drought Mitigation Center. Um, been around since 95, and I've been with the center since 95 and been the director the last 10 or so years. So we have a staff right now of about 21 folks, and then in addition to that, 6 students. Our mission is in the three blue bubbles on the left. That's our primary mission areas. These are what we call the three pillars of drought risk management. And our job as a boundary organization, sort of in the middle there, is to translate all that science into stuff for our audiences in the green bubbles on the right, and translate that science into information that is usable. So the key word there being usable. A lot of our products I'll show you have been co-designed and co-developed with partners at the tribal, state, federal level. And I think that in and of itself makes it more usable. Wherever we work. So personally, I've worked in over 80 countries now in my 30-year career here, and the center has worked with about 105. So that equates to almost half of the world's countries. The Drought Mitigation Center has worked with either hosting them here, going there, conducting workshops, tech transfer, and learning from them as well. I'll say this, it is a two-way street. Drought in the tropics is completely different than droughts in the continental parts of the different continents here across the world. But in general, a lot of the issues are the same. The people have the same problems. And so it's a very rewarding effort to work at this scale with so many people over my career. So I showed this one before, Henry, and I'm going to show it again because I think it's pretty funny. And it's really been applicable this year. It was pretty eerie. The last time I did this was in 2013. We were coming off a very bad drought in 2012, and most of the trees felt like this in 2012, that they were begging the dogs to come over away from the fire hydrant. So one of those classic Henry jokes of how dry is it? You're all familiar with the standard co-op or sort of CoCoRaHS, the 4-inch gauge to collect precipitation. Recently around here, after only 6, 7 inches of snow, which is way below normal for Nebraska, and I know most of the West has had a very bad snowpack year. We'll talk about that later. This is our new snow gauge, our rain collection gauge. So these will be a lot cheaper for CoCoRaHS to distribute if it ever stays this bad, and we hope it doesn't. So let's just start off. What is drought, right? I think people look at this picture and they're going to think, is that a white horse with black stripes or is it a black horse with white stripes? The truth is it's a zebra and it applies to both, right? It's in the eye of the beholder. Whereas flooding, we're going to think of a more rapid onset sort of thing compared to drought. It's all relative, of course, but you might think of flooding as more of a quick hitter, although they can last days or weeks too, depending on the situation. All these photos I'm showing you are kind of, Henry asked me that question up front of what got you into this. Growing up, I was in high school in the big floods of, I take that back, I was in college in 93 with the big floods on the Missouri into the Mississippi. And these are just some photos from that massive flooding event over the summer that came on and really across the entire basin from north to south. It was a pretty amazing event. And of course, tornadoes. Now, this tornado is the infamous Hallam tornado. That width of that wedge right there is 2.5 miles across. Now, I could see the funnel, I could see the wall cloud. I could not see the funnel from my house about 10 miles north of that. That's not me in the car, by the way. So live to talk drought another day, as they say. But this was a huge tornado that totally wiped out the town of Hallam, which is just south of Lincoln. And so I could see the entire sky churning above me, kind of like from that Ghostbusters image back in the day. So more people think of this when they think of drought, right? Kind of slow onset, even creeping, as Henry mentioned. And I think that's still true, although I hope to change your mind that it can also be this. It can also be what we call flash drought, and that's a term I coined back in the early 90s with the whole idea of getting people to not just think droughts only take months or years to manifest. They can indeed come on in weeks or days, especially when they concur and coincide with heat waves, where you have hot, windy conditions and high temperatures. You can really suck a lot of water out of the profile, out of the plants, evaporation, transpiration, all that good stuff. And things can go bad in a hurry, especially if it's at a critical time in the growing cycle for crops and natural gardens and landscapes. This is what happened in 2012. So 2012 was the real defining flash drought, even though I'd thrown the term around about 12 years earlier than that, based on some rapid onset droughts in the southern plains that coincided with heat waves. Now, iconically, you'll probably think of this when you think of drought as the Dust Bowl years, right? There's been a lot of great coverage of that, the displacement of people. Uh, Rain follows the plow did not apply anymore. Folks were devastated. Those dunes on the bottom right there, going up over rooftops, and massive dust storms, and a lot of people just picked up and left. This is not the 1930s. This is a combination of droughts just since 2000, I should say. The big dust storm that have been frequent across the region, the one on the bottom left, is the Texas Panhandle. The one on the bottom right is Phoenix. They call those haboobs, which you will hear termed in desert areas for sandstorms. But on the top right there, that was 2012. That was a huge drifting of sand dunes over fence lines. It's kind of hard to see that. I'll kind of rotate my mouse here. This big grain silo, this was a fence line right along here. That migrating dust has gone up over that fence line. This is in the panhandle of Oklahoma in 2008. Just nothing's growing there, right? Complete loss. So very similar features, although not as bad based on a lot of the conservation practices put in place after the 30s drought. The formation of the Soil Conservation Service, which is now known as the Natural Resources Conservation Service, put in a lot of mitigation actions, windbreaks and no-till sort of practices, things to reduce this. But you cannot totally stop Mother Nature from doing what she's going to do. I think that's the main lesson. Now, this is me and my colleague, Mike Hayes, the former director of the Drought Center. We're doing a little drought chasing here in western Nebraska. That corn is a total loss that you can see there with my colleague. And there were a lot of grasshoppers that year, and we had some really good photos of grasshoppers eating paint off of houses and sitting on the shoulders of my colleague there. But you can see, obviously, a lot of the streams that you would expect to still see water flowing. I think this was June too. This wasn't, or maybe it was July, but it still shows you sort of what the impacts are. This is not Lake Mead. This is not Hoover Dam, but this is rather a very, very large reservoir in western Nebraska called Lake McConaughey, and you can see how low that water level is. The water line was about up to here normally, and it was way down. That made for some huge, nice white sandy beaches, and a lot of folks from Colorado and the surrounding area go to Lake McConaughey for recreational activity. And of course, we can't just sort of disconnect drought and fire a lot of times. These were large fires in 2012 across the Texas bushland and grasslands in western Texas. A lot of devastation to cattle and ranches and fences. I mean, thousands of miles of fences that needed repaired. And this was just something we saw here in 2006. Now, this is the fires in western Nebraska. Almost, over 900,000 acres, which is quite a lot. A lot of that's from the dry winter. You've had a lot of burning of range and pasture land. This is the Sandhills region in Nebraska, up into the Pine Ridge area. In the Panhandle, we've had some huge fires. That's what the upper right photo is. And you can see here on the drought monitor map, these dry conditions, these fires are right in these areas where it's pretty bad. And this is a concern across a large portion of the West, given the lack of snow and warm temperatures early in the year. Early melt-off is going to expose a lot of vegetation to potential fire danger as we move into the summer. So drought poses a lot of challenges when you think about how do we monitor it. As I like to say, it goes from days to decades. Flash drought on the order of just days or weeks, and moving across into ecological, agricultural, hydrological, which then affects sort of surface water and groundwater as you get out to 6, 9, 12 months out to years, which is an issue in the West here, where we look at things in terms of multi-year droughts. These are the scales we're working on. And on the vertical axis on the left here, up and down, y-axis, we see how drought affects local areas and hits that very hard and scales all the way up to continental features, large-scale droughts, kind of like what we're seeing this year. So just not to bore you too much with definitions, but a lot of times there's confusion in the difference between drought, which is a temporary feature of the climate. It's a very normal part of our climate. It has been. If you go back and look at tree rings back thousands of years, there's a natural ebb and flow of drought and normal and above normal conditions. But not to be confused with aridity, which we see in the West, where that's relatively a quasi-permanent feature. Now, of course, over time, and we've been going through what we call a mega drought, sort of a multi-decadal drought that lasts one or more decades. We've seen that predominate in the southwestern United States really since the turn of the century and is still going. Now, you've had a couple okay years in there, But all in all, when you look at that 20 plus year period since 1999, the winter of 99 2000, most of the years have been below normal snowpack. It's over allocated. The demand is still very high, especially when you're in drought. The demand's going to be even higher. And so we've had a lot of impact on the Colorado River system, particularly in the lower basin. And that's going to cause big problems. In fact, they could be looking at very little capacity to generate electricity, which serves thousands of people. The water serves millions of people, and that could be in real jeopardy by the end of this summer, especially with the kind of winter we had, lack of snow. We had some good rains early, but you wanted it to snow so it melts out slowly instead of running through the system. So that's the main difference between sort of drought and aridity. And then water scarcity, you can have a normal year above normal year and still have water scarcity because the demand strips out and exceeds the supply. So these are the differences between some of these key terms. So that's sort of our role in water scarcity and desertification. Now, this is probably the biggest problem when it comes to dealing with drought, and that's just human nature. And human nature is when you have rain, apathy sets in as we go clockwise around the wheel here. Even when drought's emerging, we're seeing signs, but yet we ignore it. We become aware when it finally begins to impact us. And then when things get really bad, we call 911. This continuous loop repeats itself, rinse and repeat all the time. And and this does apply to many hazards, but certainly with drought, as it's a little bit more sneaky, not as quite as visible as other hazards, and this leads to this apathy. And this is the goal of our center has been over our 30 plus years of existence is to focus on being more proactive versus reactive. And that's what mitigation is in the terms of drought. In terms of climate change, mitigation would mean something like let's reduce greenhouse gas emissions. Excuse me. With drought, it's about what can we do in advance of drought to reduce the impact of drought? How do we reduce our vulnerability? How do we increase our resilience? So again, that thing that most people think of drought is, oh, I've got time. It's slow onset. We'll deal with it later. But I'm going to show you some more information a little bit later on flash drought. The question I have, or is it? I don't think we should be assuming that anymore. A couple things at play here. Increasing temperatures over the last 2 or 3 decades have changed the characteristics of drought. It's changed the behavior of drought. It's changed how fast water goes through the water cycle. This puts more strain on resources. This puts more strain on capacity to deal with it. And that hydroillogical cycle is speeding up the hydrologic cycle, if you will. The other thing is there is no universal one size fits all definition. So if I asked all the people on today's webinar what their definition is of drought, I bet you we'd have over 100 definitions. The other thing is you typically don't see the impacts, at least in the United States. It's typically non-structural, although shrink swell of clay soils does have an impact on foundations. But in a lot of cases, droughts are very beneficial for the construction industry, viticulture, tourism, and recreation. They don't like it to be super rainy. So not everyone's a loser. I'll just say that up front too. But typically, the famine issue comes into play when we deal with developing countries, and there it is a matter of life or death. So it's all relative, though, to your vocation and where you live. So our progress has been slow. I mean, I think we made a lot of progress in our 30 years. We've gone from 5 states with drought plans to 48 states with drought plans. I think that's we've worked with about 3 dozen of those, so 3/4 of those states, and helping them in one fashion or another update, replace, or develop a new drought plan. Which again focuses on those 3 pillars I talked about up front, which is monitoring drought, sort of the early warning, risk and vulnerability assessments, how does drought affect you, and then mitigation policy and planning. I've touched on a few of these already, but again, there are many types of droughts, from the very shorter meteorological flash sort of droughts, Flash doesn't necessarily mean that it's just going to stop after 2 weeks and 3 weeks or 3 months and it's done. It can manifest itself into any of those droughts below it, ecological, agricultural, or hydrological. It's just a matter of how long conditions allow it to fester, if you will. So in our monitoring system, this cartoon on the left is generally the water or hydrologic cycle. We're trying to use indicators, whether they be in place observations, what we call in situ observations. They could be modeled, they could be remotely sensed from satellites or drones or planes. And we use all of that data in the making of the drought map, which I'll show you here in a little bit. So we're trying to extract out conditions at all of these parts of the water cycle on the left. The other important piece is on the right, and that's impacts. If there's no impact, is there a drought? It's kind of like the adage of a tree falls in the forest and no one's there, does it make a sound? It's kind of like if drought happens in the desert, does anyone see it? That's kind of the way drought works, though. But, we're doing a better job now. We started a comprehensive national impact collection tool back in 2005, and now we have several thousands and thousands of impact reports. And as I'll mention later on, we went into it, worked with our friends at CoCoRaHS and Henry Shop to develop a way of bringing in the drought impacts through the CoCoRaHS Observer Network right in to our national database. And we'll show you that in a little bit. So this is our state of the science. This is the U.S. Drought Monitor that I helped co-found back in the late 90s, and I authored it for 17 years. I have not authored it since I became director here, so for about 10 years. It's a joint effort between NOAA, USDA, and the Drought Center. And I will add that this year we have just added NASA to the team. So we have 2 new authors that will come on board later this year. We're training them up. They're visiting the Drought Center here in April. And we will get them up to speed, and they'll be part of the team. So we'll have 4 partners beginning later this year. We also have, I think what's very unique to this process is that we have over 400 what I would call drought subject matter experts on the ground across the United States. They provide real-time feedback to the map and the drafts every week. And there's over 400 now. We had close to 500, and then with all the government cutbacks this last year, put a real dent in our user community and reduced our ranks to about 400. I'll talk a little bit more about the convergence of evidence and what that means. How do we make this map? And what I will say too is that this is the main trigger in policy implications for the U.S., primarily through the Farm Bill. Livestock forage program had no safety net at all. And I call this science before policy. So that's what's in the top left. We did not make this map on a mandate from somebody. We developed the science, we built the product, it was running. Others started to see it, decision and policymakers and politicians. And as they learned more about it, they started to adopt it as a trigger for these various plans. So the Farm Bill is the big one. Half a dozen or more plans are tied to it. Livestock forage being the largest. All of those plans, it's led to about $30 billion in emergency response from Congress over the last, since 2008. But the Internal Revenue Service, Federal Reserve Board, Centers for Disease Control, the Federal Energy Recommissioning Group, and on and on and on, including many states. So it has become the go-to map for drought in the U.S. This is the current map from just last week. You can see quite a bit of drought across the country, about 50%. So we're approaching 1,400 maps. We haven't missed a week since we started in August of 1999. What do those colors mean? So D4 is the worst, right? And that's a 1 in 50 to 1 in 100 year sort of drought. Very low percentiles. What we start to call droughts up there at D1, which is at what we're saying between the 11th and 20th percentile, something you'd see about once every 5 to 10 years. And then the yellow is just sort of a heads up. Hey, it's dry. It's about the 30th percentile, something you're going to see very frequently, once every 3 years or so. And the rest, we don't cover any flooding. A lot of people do that, so we just stick to drought. This is another way to look at it. If I had 100 years of ranked data, only my two little raindrops in the bottom right there that I'm toggling on and off, that's it. That's about how often you should expect to see D4 in your neighborhood. Now it's like flooding. Like when you hear about a 1 in 100 year flood, sure, it can happen the very next year or the very next month. So, and with non-stationarity in play, given warming climate, we can't just rely on past to predict the future. It's not a one-to-one analog. So things are changing. Now for D3, now I'm looking at the lowest five sort of occurrences for a given location. When I go to D2, now I'm looking at the bottom 10 and D0, the bottom 30. So you could do the same thing for the wet percentiles on top with the green raindrops there. But this just gives you an idea, and then that's tied to an amount of precipitation for any period of record, for any given time within a period of record, I should say. So we're looking at all different time scales from what happened this week compared to last month, compared to 3 months, 6 months, 12 months, multiple years, and we can do this ranking at all those different time scales for each of those parameters that I'm going to show you. So again, we're trying to capture more than just rain and snow. I mean, precipitation is the big one, but again, with increased temperatures in a warmer atmosphere, you can hold more moisture and you can actually have more rain or precip, but have it be less effective because it's going to evaporate off quicker. It's not as effective getting into the soil or into groundwater. So it's complicated and it's not an easy task. And again, at the top, across in the blue arrows there, we're looking at all those time scale features I just mentioned earlier. I mentioned convergence of evidence. Really what you're trying to do, you see this Venn diagram. The author sitting there in the middle trying to make sense of all that is using machine learning. They're using expert judgment. They're using those network of experts of 400. They're looking at impacts. They're looking at dozens of indicators. And they're trying to make a map for all 50 states in less than 3 days. They're also doing the Puerto Rico, Virgin Islands, and the U.S. affiliated Pacific Islands. So it's a monumental task. These are some of the sort of indicators we look at. There's a lot of different indicators, whether that's stream flow or snowpack, snow water equivalent, groundwater, and many, many drought indices, stream flow and runoff, et cetera. And then that input on the blue circle here in the bottom left, expert local input and impacts. That's very critical as well. That first map right there I'm showing you is the August 399 map that I helped make, myself and another expert at the Climate Prediction Center, Doug LeCompte. We showed this in August of 99. The very next week, there was a press release at the White House on August 11th saying this product's going operational. So it might have been the shortest lived governmental experimental product ever. Usually those can be in experimental status for months or years. So we had to ramp up very quickly. And now we're looking at dozens of indicators using GIS and machine learning, a lot of cool tools at our disposal. Here are just a few of them. Again, on the top right, that's the hydrologic water cycle. And on the bottom here, these are new tools that have come about. Almost all of these, except for one, came about after the big 2012 flash drought. So there's been a lot of research and development on capturing these, what I've circled in red in the cartoon, from the atmospheric to the soil moisture to the water, whether it be surface or subsurface, and even vegetation conditions and evapotranspiration, to develop a lot of new indicators, which I show with the examples in those maps along the bottom. That's really helped the authors make a more accurate map, and it's helped the authors really be more responsive to drought and not see these, what we call latency or lags between conditions and when that gets on the map. So the big 2012 drought, I think most people, if they're being honest, the models, the indicators, they were off by weeks. In some cases, 4 to 6 weeks off. Now I think we're down to less than 1 week, like maybe 4 days. So we've made huge strides, not perfect, but we're getting there. The satellite technology, the machine learning technology really lets us analyze and study big data quickly. These are all gridded data. that you're talking millions of grids and large data. You need a lot of processing power to sort of look at how that drives the picture of the map. So those of you who are familiar with the Terminator movies, this is what I jokingly call Rise of the Machines. This is our attempt at using machine learning, sort of the new generation. This is our third generation of these products. They get more accurate, they get higher resolution. We vet these with those 400 people. We vet these in the academic literature, and then we just vet them operationally. I mean, nothing works better than just seeing how these things do week to week. Where do they do well? Where do they not do well? So, how do we build in regional and seasonal characteristics of drought in the Pacific Northwest versus Florida, or New England versus the desert Southwest? They're all going to behave differently. But all these products are based on the climatology of those regions. And they're based on feedback from folks that have helped us evaluate these tools. And no doubt about it, it's helped us do a lot better job of picking out in mountainous areas the slope and aspect and orientation and just a lot better job than I remember doing the map back in '99 with like 6 products and 3 of them were sent in the mail. So I mean, the internet was relatively new. Email was just hadn't been around even 5 years yet. So things have really changed in how we process and make the map over the last 25 years. Now, I want to also touch base here a little bit on the impacts, and then what I'll do to wrap up before taking questions is give you just a little flavor of where we are with the current drought and maybe where we're going in 2026. But I want to make sure I'd be remiss if I didn't talk about drought impacts. To me, all droughts are local. That's kind of tongue in cheek, but it's not. I mean, a lot of times at the national level, when I work with the United Nations and the World Bank and others, and they're always tied up on, well, what percent of the GDP is that? The gross domestic product, and that's not how you should really look at drought. Because if you look at large areas of countries or states, when a drought comes in and totally wipes out their crops that year, or they have to cull their livestock herds. In other countries, that's their bank. I mean, their livestock herds are their currency. It's devastating. And so I don't think you can just simply say, yeah, that affected 3% or 4% of the GDP that year. It's a ripple effect. The global markets, the commodities are so connected now that there's huge ripple effects when you see a reduction in wheat in Europe or Australia or the United States and how those things move around these days. And then you throw a couple wars in there and it's even worse. So these shock events, if you will, including climate and drought. Impacts help us understand that better. We need to do that to establish a monitoring baseline, just like we do for precip or temperature. Any country I work with now, I tell them right up front that impact collection tool needs to be a regular part of your monitoring, just like it is for precip or temperature or soil moisture. And the other thing this really does is it helps us ground truth the satellite-based or model-based indicators that they make sense. So if you've got a satellite product that's saying this drought is the worst it's ever seen over the last 3 months, and there's absolutely no impacts on the ground, maybe something's wrong with that indicator. And so then we dive in, and not we, but the research community. The drought monitor is really a huge data consumer. The only real data we produce is the drought map itself, based on a lot of these indicators. So there is no one single method existing or sort of a systematic impact collection effort, and it's really a bunch of different people. They're much more on the same page than they used to be as well from 20 years ago when we started in 2005. And there's a long ways to go, though. So one of the things we did, and this is, and I'll get into sort of the CoCoRaHS element of this. To me, again, impacts are the face of drought. Here you can see a map with the drought monitor underneath of the impact station. So if I just hover over one of these stations, if that user submitted a photo through their smartphone, through the little quick survey, it'll pop up and it'll give me the report of what that observer said. Very similar to what you would do in CoCoRaHS. And in fact, we're able to import in a lot of the CoCoRaHS stuff into our national drought database now too. So what you all do is just really critically important. It's also important for the drought monitor authors to see if I had a bunch of red dots up here in Minnesota and I don't have any drought up there. What's going on? Is that a recovering drought and that's just deep well levels and things have been getting much, much better over the last 6 months or a year? Or do we need to think about expanding drought into that area? And it works both ways. It validates we do see a lot of dark red drought dots across here where that user has sort of corroborated, if you will, that they're seeing dry conditions in their backyard or on their farm or their ranch. And so it's been quite a while now, Henry. I can't remember exactly how many years, but I would say over a decade now, or right at that time frame, where we started working with them. And through the CoCoRaHS interface, you had a captive audience of really engaged citizen science folks, crowdsourcing, if you will, that have an interest in these sorts of things. How can we collect drought information from them and what they're seeing, or the impacts on their stream going through their property, or maybe their yards or their gardens or the trees, or not seeing this flower bloom this year, et cetera. So we've really enjoyed this relationship. They've done a great job of promoting drop impact collection. You can see her on the right side. And I would encourage all of you that are listening, if you're not already doing this, you're really helping us out too when you go in and put in your drought impacts within your activities. And that's something we just, again, we use it. The authors use it. It's a nice little ground sanity truth, if you will. And they've done a lot of great educational material on that at the CoCoRaHS website. And of course, some of my favorite sayings that have come out of that, you know, are cows giving you powdered milk? Enter that impact. Is drinking water tasting dusty? Enter that impact. So again, drought's a lot of things to a lot of people. We don't care. Put it in there. It's all right. We'll take a look at it. We might not listen to so much that if it was caused by a touchdown of an alien spaceship or something like that. But if you've got photos, then we'll believe it, and we'll go ahead and put those in there. We'll post it. So again, all droughts and impacts therefore are local. Drought is on par right with hurricanes as the number one cause of economic loss. And globally, it's the number one hazard when you take into account loss of life. So drought is something we should not ignore, yet it's often ignored and often deal with after the fact. It just needs to be a much more integral part of our day-to-day monitoring of conditions across our country and the world. And I showed you the See More interface, and here's the drought reporter. Welcome to come take a look at either of those. Now, I want to show just a few things on flash drought and then finish with sort of the current state of the drought. These are what we call either a rapid onset drought or a rapidly intensifying drought. Again, the old adage was droughts takes months or years to develop, and I don't think that's true anymore. That got quite a bit of pushback probably early on when I first sort of broached the idea in the early 2000s, and now I think it's mainstream. I get asked to review multiple papers every week from around the world about flash drought. So I think and especially other countries that are seeing even more pronounced increased temperatures, how it really is changing the way droughts behave and how we therefore need to monitor them. So there's a lot of flash drought sort of early warning challenges and opportunities. Days to decades I talked about, there's sort of this fatigue of monitoring. That's what also makes CoCoRaHS observers so unique is the diligent passion of entering in precip rain, hail, snow, whatever, drought, hopefully. And so I feel that flash drought can be the torchbearer for better drought early warning. Instead of that mindset, oh, we can wait, we've got time. Because really, if you think about it with drought, yeah, flash drought can still be weeks, days or weeks, so it's not like minutes. But there's no excuse for having drought sneak up on you. And so really it comes back to this whole apathy is the key part of the hydrological cycle here that I showed up front. All right, I've already talked about this. So one thing I do want to mention on this slide, the reason I had it in here is I think it's not about our tool set anymore, it's about our mindset. And that goes kind of back to the apathy part. But we've got so much data now. that's not the problem we can use as an excuse like we could 20 years ago. It's really now about our mindset and impressing that upon decision makers and policymakers that their time horizons in office are relatively short in most cases. Um, but there's constant turnover, there's new staffers. So getting them to understand that they need to also deal with drought on a shorter timeline, I think is important for moving the needle forward on future planning at all scales, whether it's at the local, community, water utility, tribe, state, or even the country. Now, many of you heard of Day Zero, right? The big drought in South Africa and Cape Town, and oh, there's only going to be so many days left. What I don't think people realize is in the late 90s, this is a photo of the Georgia State climatologist uh, measuring, in cartoon form, measuring the level of Lake Lanier, which feeds Atlanta, which is a large metropolitan area. They were literally um, a month and a half or so out of having no water for Atlanta. They were already making plans to fly in, tank in, train in, truck in bottled water for 5 million people. That would have been crazy. They have a relatively small catchment zone for Lake Lanier. All water flows out of Georgia, none flows into it, if you can believe that. And so this was Atlanta, day zero is the first instance of this, well before South Africa. So don't think it can't happen here because it can. And if Lake Mead gets any lower and we can't generate electricity, it can happen here, folks. And I think, again, it's a mindset, not a tool set. All right, so let's wrap up by looking at where we are now and maybe a little bit into where we're going. I showed this current situation map a little bit ago. You can see quite a bit of drought. And you've heard a lot about the drought in the West. Not as much maybe in the Sierra Cascade or Sierra Nevadas. Um, and a lot of that was due to these huge atmospheric river events that occurred early in the water year, a water year being October 1 to present. And so the problem with that is, yeah, it's a lot of rain. That's great. It can have some short-term effect on maybe their reservoirs. And that's why you don't see quite a severe drought situation in the West along the Pacific Ocean. However, that doesn't mean it came in the form of snow. It came what we call a phase change. It's rain, not snow. So as you go west into the Wasatch and you get over into the Rockies, we saw a very low snow pack season so far. And time's pretty much basically run out. Typically by April 1, you're what you got's what you're going to get. And you hope it stays cool. We've had quite the opposite happen. So we've had extremely warm temperatures. We've had a warm winter in general. And we haven't had a lot of snow. Those are not good. It's not a good recipe for recovery. It's not a good recipe for what's going to flow in from the upper Colorado into the lower Colorado this summer. And then we also have pretty good drought across the southern tier states and Gulf Coast states over into the mid-Atlantic. So a lot of drought in a lot of places. I mentioned the fires in Nebraska earlier. I think it could be the fire season is going to be challenging. If we look at the changes since the beginning of the year in the top left, you can see as you get to the darker colors of yellow and orange and dark brown, that's the degradation. That's just how much the drought has degraded from the Mississippi West and parts of the Mid-Atlantic and Florida since January 1. As you go to the bottom right, though, that's the water year. So we do see some blues. Again, I was talking about these atmospheric rivers. They brought a lot of precip, but mostly in the form of rain. So they're not out of the woods either. But as you get into the Rockies here, the spine of the Rockies, um, except for maybe in Montana and the Bitterroot region, you've got a lot of concerns for feeding the lower basin this summer. And then the drought we see has really degraded across the Gulf Coast states and the Central Plains. Now, the snow water equivalent, I've never seen a map this red as of March 31st, any given year. This is dire. That's why, even though it was wet up here, it was the form of rain and not snow. That means you're not going to have snow to melt out in the summer. That's going to affect irrigation allocations. That's going to affect fire, lots of things going forward, including natural, environmental, forested areas, orchards, you name it. it's going to have an impact. And this is not a good situation as we head into. It doesn't mean there can't be another last gas snowstorm here or something in April, but with the warm temperatures, the warm soils, things are just going to melt off quickly or be absorbed very quickly. That won't be super effective. There's a smattering of better conditions here up around Yellowstone. But in general, this is as red as you'll ever see a map. This is what you would expect to see in maybe May or June. 2 months. We're 2 months ahead of that pace, no doubt about it. On top of that, for the southern tier states, maybe a glimmer of hope is the forecast for the development of El Nino is very strong. And not only that the odds are with the development of an El Nino beginning this spring and summer, persisting through the end of the year. You can see down here in the blue, these are the La Nina forecasts, very low probabilities, and then neutral when sea surface temperatures are about average. Those are at 20% or so as we get into the summer period, June, July, August, through November, December, January. The red bars, however, are what they're calling the El Nino forecast probability, sitting up here around 70%, beginning in May, June, July period. Even April, May, June, it's about 50-50. Not only do they think this El Nino will develop and they have a strong likelihood of developing, but they feel it will be a super El Nino, which is the warmest of the El Ninos, which can have major impacts. So El Nino winters, this next winter, what we would expect though would be some improvement along these southern tier states. So that could be the good news. Warmer and drier up here may not be as good a news in terms of snowpack next winter in the Northwest, where they had good rains but not snow. It's always a little bit more transitional and dicey to predict here in the Rockies. But anyway, this is kind of where it's looking like it's going is El Nino versus over here the La Nina pattern, which is a drier, warmer pattern across the southern U.S. What does that mean for temperature and precip over the next month to 3 months? I'm just going to focus on the next 3 months on the bottom. Bottom left, this is seasonal temperature outlook. Pretty much increased probabilities for above normal temperatures across almost the entire country, except for parts of the Great Lakes region and New England. And then when you look at precipitation, a below normal wedge here from the Pacific Northwest into the Central Plains. And the East Coast could be a little greater odds of above normal precipitation. And again, that's for the April, May, June period. What does that mean for drought then? Well, I think those areas that weren't in drought with the AR events, those atmospheric river events, looking like that could be going to development of drought is very likely as they go into their dry season. So all the yellow areas, if you look at that, just pretty much from the Missouri, Mississippi River westward, it's going to be all red there in the coming months. And this is again through the April through June period. So, 25-6 fall winter was not too kind to us. We're going to be really living rain to rain as we go into the growing season, and that's not what you want to do in a variable climate. We could get lucky, but we've got a big hill to climb. We're not going to make up deficits that are critical for major systems like the Colorado, and then we'll have to see what next winter brings. So the spring is pretty important though for planting and cropping of crops across the grain belt in our central part of our country. So this is the bottom line: no water, no life. This is the essence of drought, basically, especially in developing countries and other parts of the world. And these are the future challenges that we face. Drought's a transboundary issue that cuts across states. It doesn't recognize political boundaries. And I want to focus on this bullet down here about promoting and encouraging citizen science because that's what you all do. What you're doing really matters, and we really use that data and that information. So I just want to encourage you to keep doing it. And these slides will be available for you to read through later on. So I won't bore you with any more details. Henry, I'm going to stop there. Thank you for your attention, and I welcome any questions you may have.
Mark, thank you so much. Always a pleasure to have you. In fact, could you leave that last slide up? Is it possible to do that?
I will do that. Let me share it again.
Just for folks that would like that information. One thing you did mention, and we really appreciate folks out there who do condition monitoring reporting for CoCoRaHS. That is something you may not be doing right now, but it's an easy thing to do. You go on the web or on your phone or on the website. You'll see a button there for condition monitoring. You put in, there's some bars there, some dials. Well, I guess they're buttons. There we go, buttons. Severely dry, mildly dry, near normal, mildly wet, severely wet. And we ask if you could do that maybe once a week. It's very easy to do. You just click on the button, you put that in, and then you can take a picture as well and upload your picture there, just as Mark has them doing on the Drought Mitigation Center site. But our reports do get put in with theirs. This helps with early drought detection and we're coming out of drought. And so what's neat about this, if you do it on Sundays, we're asking folks maybe Sunday morning when they take their observation or anytime over the weekend, the drought monitor authors take a look at this on Monday and Tuesday, and they are looking at these reports. Anecdotal stuff, you can write in there what it looks like. My ponds are dry, or yeah, my cows are giving powdered milk. And that kind of stuff really helps paint the picture. They look at this and then they put their reports together, and then the drought monitor maps come out on Thursday. Is that right, Mark? It's Thursday.
Yep, Thursday morning.
Thursday morning that's released. So you can really help with that. And the more folks that do that, the better picture folks will have with on what's going on with that. Well, let's take a few questions here. We've got plenty of them. And again, those that Mark is unable to answer during the talk today, we will or he will follow up with you via email. So thank you for your presentation, Mark, and thank you folks for watching this. Um, Again, here's an interesting question. Danielle wonders, where can you find out what your state drought plan is? So where do you find that?
So if you come to our website, which is just right here at drought.unl.edu, we have a planning tab on the top there. And if you click on that tab, you'll see a map. You'll be able to go to a map of the United States, and we have a link to every state that has a drought plan.
Okay, thanks. Here's a viewer in Ohio wants to know if it's dry for long enough, will it be harder for fires to start because the brush is all dead or gone?
Yeah, that's a good point. Sometimes the worst fire seasons are after wet years, not after dry years. Why? Because you have what they call fuel load, but typically that's on consecutive dry years. You might not have a lot of fuel or grasses or shrubs, or if it's burned in that region recently, that's going to keep down the fire risk. But um, that does play a role, though, is kind of what happened over the last year or two in developing the vegetation that dies off versus if it's dry, you're not going to have as much to burn.
Okay, Jim writes in, does replacing water in the ground after drought return it to its original health or are there permanent harms?
Good question. Now, there are efforts, especially in the West, to capture during the good times. Phoenix is doing this, or Arizona's doing this. They're literally trying, when big floodwaters come down arroyos, can we capture that and pump it underground into the aquifers so that we can use it and extract it during drought years? Um, to my knowledge, I mean, it's not gonna, you wouldn't necessarily have an immediate environmental reaction to that because you're putting that water underground. You're not throwing that water out across the landscape, so to speak. Whether it's Arizona or whether it's Nebraska, it doesn't really matter, whatever state you live in. But I think these are the sort of things that people are thinking more and more about is how far can technology keep us out of harm's way? I don't think you can outrun it forever, and demand continues to grow. So we have to do it smartly. Technology can only take us so far. At some point, we've got to do more with less.
Okay, thanks. David wants to know, can you speak to the effectiveness of programs to increase moisture such as cloud seeding? Does that help with drought?
So in times of drought, you're typically high pressure dominated conditions in general, ridging. You don't have any clouds to seed. The folks in the states that are investing in cloud seeding are doing that as a long-term mitigation action. So for two reasons. One, when there are clouds to milk more moisture out of it and put that into their reservoirs and streams or soil moisture. And secondly, it's the insurance sees it as a potential hail mitigation action as well. For drought, though, it's not a short term. If you're in drought, you're not going to see clouds when there aren't clouds. So I think the jury's still out on how effective it is. And also, you got to keep in mind, where do you seed the cloud? That do your neighbors downwind get the benefits of your cloud seeding because it therefore rained or snowed a state over, so to speak. So that's kind of riding the atmospheric current, if you will. So there's still challenges with that, but it's invested in around the world and in the Western U.S. in particular.
Okay, Rick in New Hampshire once, he was wondering if he'd like to see two drought indices, one for lawns and annual crops and one for groundwater and wells. Is that something you guys have thought about?
There is a lawn and water or lawn and garden, I think it's called lawn and garden index. It's generated by the University of Alabama, Huntsville. I think they do it for the southern region of the United States. I don't think they do that nationwide. Um, I think if someone had the resources and wherewithal, they could probably, if they were willing to share the indicator and the methodology and the code, could you extrapolate that? I think you probably could. So there is something being done, but just not nationally. And I've seen the product, and it's a good product for that region. It works well. And what was the second part of that question? Groundwater indicator?
Yes, so groundwater.
So the biggest problem with groundwater is unlike precip and temperature, we don't have an extensive groundwater monitoring network compared to our precipitation. Now, the USGS maintains several sort of longer term wells, more what we call natural occurrence wells. So they're in areas that aren't irrigated. So the well levels won't be influenced by pumping. But that's this very small network in general. I mean, a state might have a handful or a dozen. And some states don't have very many, and they don't treat that network the same because of resources. So I think there's some challenges there. It's a huge gap. Um, we can use a remotely sensed tool from NASA to penetrate using gravity. They have a gravimetric sort of indicator for groundwater, but it's very coarse resolution, like on the order of 500-mile pixels. So it can show, and it does show changes in water table for longer term droughts. But I think we need to do a better job of investing in groundwater indicators, even in our country. So we use what we got, but it's probably not enough. Just like we probably don't have enough in the terms of soil moisture or snow catching stations across different mountain ranges. A lot of challenges of maintaining and funding those networks, especially now.
Thanks. Here's a question for you. So the National Drought Mitigation Center, look, you've got University of Nebraska listed there. Are you
Yeah.
guys part of the federal government, or are you a separate entity that the government uses, looks at?
Yeah, thanks for that question. We are a separate entity. We are located at the University of Nebraska. We are not a federal agency. We work with all the federal agencies, which gives us sort of a nice, unbiased third party, objective sort of way where that, especially that partnership with the Drought Monitor, it's not just a federal product. So I think that helps with the overall perception or the integrity of the product. Um, but yeah, we're located here at UNL. So if the founding director had been in Colorado, we'd be in Colorado or we'd be in Oregon or wherever, but this is where we started and this is where we are.
Thanks. Rob wants to know, in tropical areas, would you classify the dry season as drought?
No, I would not. However, in tropical regions, and we work a lot in the Caribbean and the Pacific, when they have dry seasons, so drier than even what's normal for them, because it's not like here's the thing, like even in the tropics and droughts occur in every climate regime. So people say, oh, you can't have a drought in a rainforest. Sure, you can. If you're supposed to get 300 inches and you get 250, there's going to be an impact on that local environment. Um, if you have a drought in a desert, there's also impact. If you're supposed to get 6 inches a year and you get two, it's going to affect the local ecosystems. So the same applies to the tropics. I mean, yeah, it's a different beast there. You have pronounced tropical season that's going to be the hurricane season, if you will, that's going to be the wet season. But some of those areas have bimodal distribution where they have precip that's not just associated with tropical storms or hurricanes. as they roll off and come across the Caribbean. Um, but yeah, it's a different beast. But yeah, there's still droughts in the Caribbean, just like there's hurricanes, and their drought signals probably a little sooner and quicker though than a drought in the Midwest United States, for example. They can't afford to really go too long without that because they don't have huge underground reservoirs. Depending on the aquifer, some of the islands don't have hardly any fresh water below, so everything has to be caught, which can cause real issues fast when drought does set in. And that's typically El Nino, La Nina related for the Caribbean and the Pacific. Droughts are they're the drought makers or breakers for those both of those regions is going to be which phase of El Nino is it in.
And before we forget, we want to thank Mark and his organization there for helping us get CoCoRaHS really ramped up in Puerto Rico. They provided some funding for us there, and again, we want to definitely thank you for that. And we're seeing a pretty robust reporting now from
Yep,
that island. So again,
great partnership.
much appreciated.
You bet.
Okay, here's another one here. How does drought affect animals? So, or what effect does it have on animals?
Well, in the United States, maybe not quite as much as other parts. If you think Africa and the Serengeti, I mean, it does affect, say, migration timing and periods. In the United States, it's a big issue over large ranching operations across the central part of the country, or even out to California from the west, say the western half of the United States. If you have to truck water, that's an issue. If your well goes dry, you're going to have to dig it deeper, spend a lot of money. I think people assume if you can pump water, you're immune to the impacts of drought, and that's not true. Yes, you're better off than your neighbor that can't do that, but what you'll incur is higher input cost to maintain the herd. Feed, forage is the same issue. Forage is probably, with that and water, those are the two main things that are going to make or break a ranching operation. So that's always a challenge, and uh, you're not immune just because you can pump.
Thanks. So Randy wants to know, what are some of your reporting methods that you wish more media or would pay attention to? So is there certain things that media could really look at and say, okay, this is important.
Well, probably the impacts, I think, from although the media captures and sensationalizes, the key ones, whether it's a big fire or cities running out of water, you're going to hear about those, right? No matter where you live. I do think the media does a great job. Like if our drought monitor maps on the Weather Channel almost every day. It's on every major newspaper from coast to coast, and most local television stations show the drought monitor. We do a lot of stuff tailored right to the media to try to bring them up to speed on what that map is or what it isn't. And so I think it comes down. They're interested in the human relation stories, and so we get a lot of calls. They'll use our drought impact reporter, or we pointed them to CoCoRaHS too, by the way, Henry. We tell them if you want to know where the stories are, go read those impacts. So what you do matters.
Thanks. Patrick says here, his question for you, and let me read this. This print is small here. Has the drought monitor or has the Drought Mitigation Center considered looking at leading lagging indicators of how heat is impacting overall drought conditions, and how can these leading indicators be classified and used as a predictive tool?
Yeah, we do. In short, the short answer is in addition to the operational product, the drought monitor, we work on various research projects with partners around the country, around the world, in fact. I kind of alluded to this once or twice, maybe three times in my talk about how that increasing temperature is, in my opinion, and what the data I've seen, changing how droughts are behaving. Flash droughts, are we seeing a trend on more flash droughts happening, rapid onset or rapid intensification? I'm seeing many studies of that around the world, so you bet. And then the other thing temperature does is drives evapotranspiration rates. How fast does the water get sucked out of the plants or the soil? That's largely temperature and wind driven. So yeah, it plays a role in many, many factors. So good question.
Mark, earlier this week, and I can't remember what I've done with them. Our friend of ours, Dennis in Montana, had sent a couple questions in. Do you happen to have any of those, or you can privately reply to him if you don't have them on hand?
Did they send it to me directly or is that from
I
you?
think I forwarded them to you,
You
but
did. There were good questions. I just don't have them up on my screen right now. And
Mark
I
will
will, if
Dennis will
those are,
follow up. Yeah.
yeah, follow up with me. And then what I could do is just try to reply directly to him offline.
Okay, very good. Let's take one more question, and then the rest, Mark will follow up with you guys. Anne wanted to know if there are plans in place in the U.S. to encourage and incentivize rainwater collection and harvesting, such as they're doing in Australia, for example.
Yeah, and they're doing that in South America and Africa and many places. Now that has caught on more than it used to, and in fact, the challenge sometimes can be these local policies. The stagnant water, it has to be a certain catchment thing with a lid, and I think in most places it's legal, but check with your local authorities or your local state or municipal laws. There are these ways of ordering these rain catchment barrels, and then people are using that for gardens and irrigation of the yard, things like that. So the short answer is yes. I think that's always a wise thing is to try to, I think this is going to be a bigger stigma or overcome. That's going to be a bigger thing in the next 20 years. In my opinion, it's going to be reused water. In a way, it's all reused, right? I mean, if you think about where your water's come from and been recycled, water's a relatively finite thing, but yet our demand is not, and the demand keeps increasing. So there's going to be more and more emphasis on more efficiency and less energy to desalinate water or to reuse wastewater for gray water for drinking or irrigation in yards. And then I think even eventually getting past the taboo and stigma of drinking it. That's already being done in lots of other places, and you would not know it if they didn't tell you, or they blend it. So California built this big plant like maybe 20 years ago, and it's not being used because of the stigma. But at some point, something's got to give, right? And as we continue to grow and put more straws in the drink, the drink isn't any bigger, but there's more straws in it. So we'll have to continue to innovate, and how far technology will take us will be a key. Uh, at some point, though, um, water's life, right? So if it's not there, people are gonna have to go somewhere else.
Okay, yeah, and we do have, if you're interested in rainwater harvesting, we did a webinar on that. Oh, I think close to 10 years ago. It's in our list, and you guys are welcome to go and listen to that. But we're going to leave it there for today on the questions. And again, thank you guys for writing those in. And again, Mark will follow up with you. It's been an excellent webinar. It's been far too long since we've had you back, so we really appreciate your coming and giving us an update on things. And Mark, if you'll stick around after the webinar for a few minutes, that would be great. We got a couple questions for you.
Will
Um,
do.
yeah, so again, folks, we're starting our webinars up again this year, and pretty robust season on the horizon. And our next Weather Talk webinar will take place on May the 27th. So mark your calendars. Look for the registration to open soon, and that's when Phil Klotzbach will discuss the Atlantic Basin's hurricane variability and give us an outlook for the 2026 Atlantic hurricane season. So you'll want to be on board for that one and see that. We do record all of our webinars if you're unable to attend, and those usually made available a couple of days after they take place. Finally, folks, when signing off today, please take the survey that pops up on your screen. And a little short survey is very helpful. So until next time, this is Henry Regis for the rest of the CoCoRaHS headquarters team saying so long for now, and we wish you all a good afternoon. Take care.